Okay, this is question 10 in the geometry section. So here we go. Always read this stuff carefully before you start. In the diagram, BE, oops, it's a little bit low here, so I'll just move it up a little bit here. Anyways, there's BE, and CD are the diameters of a circle, and M is the center. Chord AE, let's look at this chord AE, is drawn to cut CD at F. Well, there we go, we're looking at it. AE is perpendicular to CD right here, or CM too, so it's perpendicular. And let angle C be X. Now give a reason why AF is equal to FE. What, if these two are equal, it means this chord AE is bisected. And the reason it's bisected is called a line from the center perpendicular to the chord. That's what it does. It cuts it into two equal pieces. A line from the center perpendicular to the chord cuts it into two pieces. So that's why AF equals FE. Now, hey, sometimes, I looked at this thing and I was looking at, angles on a diameter. They often use it. And I'm looking at the angles of the diameter, and there's such a simple thing going on here. The simple thing is this. Let's just move that over there. You see that segment CE? Well, A1 there is opening up to the same segment as M1. And that's the secret to getting it. I didn't see it right away, so I don't feel bad if you don't see it. I've been looking at these things for quite a while now, and sometimes I don't see it. Now, A1 is easy to get because they're asking you to do it in terms of X to figure out M1. That's easy because it's a triangle CFA, and you just go it's got to be add up to 180, so A1 must be 90 minus X, angles sum at a triangle. Now that's an angle at the circumference, and that's an angle at the center. So M1's got to be 180 minus 2X, because the angle at the center is 2 times the angle at the circumference. And that's all there is to it. Maybe I'll take a look at the next question. We know that that's 90 minus X. We know that that's 180 minus X. We know that CAD is equal to 90 degrees because it opens up to half a circle, a semicircle. And we're asked actually to prove, giving reasons, that AD is tangent to the circle passing through AC and F. I almost would like to make a circle here so you could see this thing. But we've got, now that we've got that CAD is 90 degrees, we know that A2 must be X because it's 90. We know that's 90 minus X. The only way that can be 90 degrees is for A2 to be X. But A2 equaling C, that's the converse of the tan-chord theorem. If this angle here between the tangent and the chord that would be in the circle going around it here, if they're equal to the angle that subtends the same chord, the angle at the top of the triangle, then that's the tan-chord theorem, makes a circle pass through those points. The converse of the tan-chord theorem makes this AD a tangent line going through a circle ACF. Well, I hope that sort of made sense. But there you go. You'd have to look for that yourself. When they say ACF, you're looking at this triangle, and there's the top of the triangle. Somehow that has to be X. Well, how can you? And you knew you had to take that stuff from before, that 90 minus X, and then you go, oh, that's 90 degrees, so that has to be X to make it add up to 90. And that's how it works.